So I want to explain you two things about the program. The first one is that we always need the software to be online. This one, Aurora. So usually what we recommend is just to go to recent projects and to open the last project which was there. And since then everything is already being connected. Like the Ethernet is good, everything is turned on. So now we are ready to go. Basically what we just need to do is to go to runtime, and that's it. So what this program is doing is you're gonna see this LED, it turned from red to green. It's not connected. There's no internet connection. So there's internet connection, Ethernet, everything is connected. Now we just go to runtime. Well, just for now that it's recording, we just go to main, recent projects, and we open the last project. Then go to runtime. So what this program does is what I think, I think it's good, but I'm gonna do something else. So what I'm gonna do is just to try to run this as an administrator, if it's possible, because sometimes there's a password. No, it doesn't matter. The last time when I was with Jens, we could make it work like this. So yeah, it was just a matter of closing the program and opening the program. So normally the program, it has this LED. When it's green, it's because it's sending data to our cloud. So basically the whole purpose of this is we have several industrial protocols. As you might have seen here, some of the machines you have there, they are connected through a serial port, which is normally a Modbus connection. This one is connecting through Ethernet, Modbus. This is the technology that is connecting this card to here. So this is the Ethernet. So what is this machine precisely? So we have the different instruments in here, and they are sending signals to the board. And then to the board, we're sending them to the this is a network. This is a network card. So in here we have 4 different modules. This is the input, this is the energy module. So in here is where you're connected to the electricity. This is the input module, and this one, and these ones are for outputs, and there's one for analogical inputs and analogical outputs. So this is basically just gathering information and is sending information to the program, so that the program is sending it to the cloud. So what's missing here to do a normal process? So what's missing here is a PLC. I've seen in the other room that you have PLCs from Festo, which are like the brain. They are programmed so that whenever there's a signal that goes to the PLC that says, right now the sensor is too high, the water sensor is high, then the PLC, the signal goes to the PLC. PLC decides what to do. Oh, when this happens, we have to do this. And it sends a feedback to the system. So either it shuts down the motor or it closes a valve or whatever. So it's a loop, which means system, card, the brain thinks, and then it sends feedback. So this is normally how it works. Now, since this system does not have a PLC or a brain, because normally the provider the original provider from this machine, they had their own brain in the computer. But now, since we wanted to move it to the cloud, we have a brain in the cloud that is analyzing everything and is going to do it. So the other part of the solution is Yaga, which is a cloud. Now, what is exactly this? So you go to Medusa Digital. See, the connection in here is...
Nimmt er das noch auf? Nimmt er das auf?
Ich habe das über die Games-Bar gestartet.
Okay, das geht auch. Ja.
Alright. So this is our website. What we are going to have to do is I'm going to give you keys so that you can go inside. And now, well, this is my password, but you're going to have yours. So the way your portal is going to be similar. This is like for because I'm the superadmin, but for yours as a teacher will be very mostly the same. Now what we have here is the brain, which is the ladder logic. So normally, how do you program a PLC is with the ladder logic, which is this one. We have different programs that decide exactly what to do and what not to do. So I'm going to open here the chemical station, which is this specific training. So this is a ladder logic program to control things. All right. So I'm going to take the time just to explain you right now how is the logic. It's very simple. So the logic is, have you ever worked with electrical circuits?
It's a contact plan.
It's a contact plan, exactly. Exactly, this is a contact plan. This is why ladder logic is more than 90% of industrial solution is this one, is ladder logic, because it's contact plan. So what we need to know in here is that we have this variables table in here. And we have all the different tags linked here. This program, you can use it like it is. What I'm telling you, I'm just explaining you for the sake of explaining you. Because normally it just works, I just have to do a click and it can connect automatically. You don't have to do anything. But I'm explaining you how it is meant to be. So we have this program, we can switch between the names of here or the ladder logic name. So the ladder logic name, for instance, here P1, which is this one. This is actually equivalent to pressing the button in here to start one of these buttons.
It's the left one.
Yes. So there is one condition for safety that I apply in here, which is the system cannot start. The system cannot start unless there is water on the system. Which one? At least the sensor, the low level sensor. If there is no water in here, the system is not going to start even if you want. As the brain, it will stop it for you. So what I'm going to do now is so for instance, this instruction is seen in here. Here is the explanation. This is part of the heating cycle. The heating cycle is just this recirculation pump who's going to pass through the heater and then just comes back. So it says in the heating cycle, this is safety. If the sensor B3 is on, then there is water minimum level at T1. But if it's off, then there's nothing, so it won't start. So this contact is linked to the start of the system. Which means,
where can I see that the contact is linked?
Exactly. So here, for instance, you have several instructions. I'm going to switch to the namings. So, for instance, this is a level switch B3, which is connected to lamp B3, which is one of these lamps in here. And now, what is done is like in here. This is connected to the normally open contact 9, which is linked to which is in the first rung. So this is the rung 1, which is this one, and this is the element. So normally, if once there's water, it turns on the lamp, and then the lamp it enables the energy to go through here. So that's the logic. So that's the initial thing. This is the first practice. And this is mostly like this is the most simple because just a recirculation, so you actually don't, you hear like the pump is pumping something, but you don't see anything. Anyways, so I'll continue explaining eventually the rest of the practice, but this is only for you as teachers. What's going on with students? The only thing you have to do is to go open. We're working right now and to make it more beautiful, but it's okay. So now you open the chemical station. This is gonna open this one. Mm-hmm. You're gonna go here to this launch VR mode, and it's gonna open the 3D experience. So this is how it's expected for the students to use it. It's just that simple. You connect here, and then everyone who's connected to the experience at the same time can be able to modify it. Just gonna reduce the sound here for. So this is what's gonna happen when they click on this this button. This is the web version of the experience, which means that even you have a mobile phone, or you have your desktop or tablet, you can see exactly the same thing. But this is meant to be used with the VR headset. So normally, in the VR headset, you go to medusadigital.com, you go into the browser, and then you do exactly the same as I did. The only difference is that in the browser with the VR headset, it's going to have a VR button in here. You click it, and then you'll be in the immersive mode, and you'll be like everything, you'll see everything like in 3D. So this is like the learning environment. This learning environment has several things which are very important to notice. So the first one is that it's multi-language. Right now this is the American language, but fucking German, doesn't matter. Well, in VR you can switch it. So anyway.
So German or?
Yes.
Okay. Wow.
Yes, we had to translate it for the European Union in Italian, Estonian, French, German. Well, we learned Spanish because we're also in Mexico. But then, and I'm missing. There was 7 languages. In the English. So it's what you have to do is you'll see that everything changes into the instructions are changed by language. Normally in VR, I'm going to open the VR so someone can follow the experience as well. So you're going to see that all the menus are in the controller, so it's more easy, it's more intuitive. What is important to tell is that here the instructions for the students are there. So what do I mean with instructions is, welcome to this, we're going to do this and we're going to do that, and then we will just keep explaining. Like we have VR controllers, we have these buttons are for turning to this way, turning the other. If you go to the X button, you'll see a chapter menu, and this is like to help people to understand the navigation. And this, well, right now I'm doing with the keyboard, but you should be able to go and switch the buttons yourself with a laser. And like everything explained, like laser and teleportation, you can interact with the different points, like this one, or even with the machine. This is the 3D, well, the digital replica of the machine. You have the buttons. You can push them, and then these are lamps. What else? So well, there's a menu. You can just go down and just see all the different instructions you have for the LC2030. Here we explain what is LC2030, why do we need to learn about this, how much does it, we have like this, always this accompanying image so that students can understand better what's going on. And so the idea is that there's this reading part. We're creating now audios about the same text so that students can also have like the auditive feedback. And we're also creating videos so that the video goes inside along with the text, so that it's more visual. Now, we explain, like we have different slides. In the slides we explain first of all what is the presentation of the machine, what do we use, why do we use this machine, and then we begin to understand more about the machine. We have different modules. We're going to handle the different variables, which is a level with water, heating. We're going to do transfer of water operations, and with the LC2030 you will understand and practice several procedures you'll need to master in chemical plants. So all of this is just like a way for students to understand what the machine is. We lately explain this is like the other water, we have the pumps and below. We explain what are these connectors, and then we say why do you need to train in one of these. So in the end, the whole idea is that the students can get a grasp on same that this is like a small laboratory, but in the end this is also a reflection of whatever they can get into more industrial scale equipment. So it's just a matter that they begin to train with this, and then the other one is similar. So this is what we want them to understand. So we explain it. And now, which are the skills that they're going to develop here? And we say we're going to put like a hands-on into the training so that they can turn on the machine, understand the different systems, understand the different things that they can do, like recirculate the water, turn on the pumps, get to understand how sensors interact with the rest of the system. We always have like these avatars. We're creating again videos from these avatars so that it's more interactive for students. And we're making everything multi-language. So yeah, so now here we begin finally explaining what's more about the LC2030. We have 2 tanks for liquid storage, 4 pumps for fluid transfer. We have sensors, we have heating system, and well, this is, we continue the explanation. So we did it so that it's more,
Oh.
yeah, you turn it on.
Okay.
It's fine. And we did this with the purpose that students can just go into the experience and learn as much as they can about the system, and they are more like self-sufficient during, I don't know, we've measured, and it's like 20-minute practice, more or less 20 to 30-minute practice. And what we want is that everything, all the information is in here. Obviously, we can always add more information as you want. That's no problem, because we've made a program to do so. It's like you say, well, you'll take a look more deeply later, but then you can tell me, oh, you know what, maybe it's good if we can explain this. Oh, it's okay, we just add more slides, and we add more videos, and we create more translations in different languages. So it's very, we made it so it's simpler just to add things, you know. About how to, now we begin like with practice, you know, finally, how to operate the heating cycle. So safety first, confirm that this lamp, which is in here, that we tell them which lamp it is. Confirm that this lamp is, well, this one B3. Confirm that this lamp is turned on, because this means that the sensor is detecting water. And now you can press the HS4 button, which is the start button, and then with this the pump M4 will begin to work like right now. Pierre has already done. And so we explain this is the first practice. Like before we explain why, what for, and what are they expecting to learn, and then they begin with the hands-on practice, and then we explain them step by step what is this. The advantage of using the desktop compared to the ladder logic is that in desktop we can allow ourselves to have the same buttons of the ladder logic in here. Like for instance, right now, Frank, for instance, if I say here hide VR mode, I can see the ladder logic. and I can see, for instance, that there's water in the level switch, so it's on, it turned automatically. And I can actually turn the system on through here, or
where did you?
so in here, I just did it in here, this button, launch VR mode. So in here, we can switch between the VR mode, and we can switch between the ladder logic.
Okay.
So there are several ways of turning on the system now. The first way is through here, through the through the VR animation, through the VR mode. So from here, I'm gonna start the heating, and you see there was it already started, and I can also like put it like just turn it off. And in here, they tell you how to do it. So everything is explained in here. Now that we are right now into the system here, with the computer, I can actually toggle exactly the same button here. So we saw that the button the ladder logic for the heating system is rung number 1, heating cycle, start pump M4. Only possible if sensor B3 is on, meaning there's water in T1. So since there is water, we know it because it's in here. Now we can start from here. We already did it with the VR. Now we do it with this. I can also stop the entire system, like in here, or I can do it with this button in here. It's the same. I'm gonna make it more bigger, more appealing, but right now, I mean, it works right now. But the aesthetics comes later. But I can also toggle in here, and it will also like turn on.
Okay.
Like, I'm gonna turn it off. And
If you use this button here, the graphic don't change?
yes, it changes so quick because the signal, it goes and it retrieves the signal, and as soon as there's a confirmation, it goes back. But I'm gonna make it that it changes the color, or maybe that it remains more time.
Okay.
This is just it goes fast, but I'm gonna do it more bigger and with different colors. Like it changes maybe between, I don't know, green and red. So
No, it was only for the short moment, not.
Yeah, but it's good to be visual, especially for students. They like it to be visual, so it's a good idea. It's a good idea. Yeah. So for instance, like now he shut off the system.
Should I shut up? Or what?
Well, I think you did because I didn't touch them.
As a system or the application?
The LC2030. You can press the button HS4.
HS5.
HS5 is to turn off, and HS4 is to turn it on. All the system turn on.
Okay. I take HS4.
I get it.
Okay.
This was good to know. This was good to know. So.
Should I?
Well, you can put it down.
Stop that?
Yeah.
Okay.
So what I was thinking is.
Stop is HS5.
So what I was thinking now that you mentioned it, yes, it is possible that everyone sees the feedback on the system. Right now, I never had the idea that it could be needed, but you're right, it makes sense. Like if we have a group of 10 people, if the water level is up to this level, if the water level is in here, then you can send with the 2 pumps water. But once you reach this one, you shut down one of the pumps, so it's easier to control the last field. And once it reaches here, everything the system stops automatically. So that's how the logic was done. Now, what we can do now that you tell me that it might be something that you do this connection with the students, what we could do is something that is actually important and what we do actually with the mechatronic scenario there is sometimes when a signal fails, it's a good practice to come here and just go and check in here what's going on. So it's like, oh, is it maybe it's not the system that is failing, maybe it's the card in here that is not sending direct anymore. So you have to check if it's working, you know. So it's normal practice. So we can maybe
Okay. And
like maybe
yeah.
put like something in there that's, oh, there's a fault, like check, and then
Okay.
and here we know already that it's a 24 volt energy, how it's called, well, power input. So it's just a matter, if you want it, we can add it. I mean.
Okay.
And also what you can do, now that the system is here, you don't even need to use this if you don't want to. Like for instance here, like this is how it looks like normally. So what is important to know about this is that we have different sources. Right now you have access to, well, to your LC2030 source. Then we have another source of data, which is the strapping machine. This is the one we did for Dresden, for Estonia. Now, for instance, in here we have already charged the different inputs and outputs that are linked to this machine. So for instance, if we just want to say, oh, you know, I know this maybe might not be like the scope of your practices, but if you really wanted to, you could. Like you can say, oh, I'm gonna add a contact.
You can build
Yeah.
by zero and
Yes, you can build it from zero, and then for instance, what we can say is, I'm gonna put this, and this is gonna be a lamp.
Mm-hmm.
So in the end, what we can do is like here, you can say, for instance, let's say P1 is gonna be what we say before is HS4. So we know that the BR tag is put on HS4.
This is the connection for the hardware.
Yeah, so this is the thing. Once you charge the experience, this means that you're going to have a VR scenario there, which is the chemical laboratory, and you know that the tags that connect with the cloud must have the same name. So for instance, here we say this is button HS4, so in here this is button HS4, and in here it's not necessary, but it's a good practice. I'm just going to rename it the same. That shit. And
what's the difference between these two tags?
All right, so BR tag is connecting from the computer, from our program to the BR to the machine in here. Well, maybe there's an error, but still. So I'm gonna save this as a test. For instance, I'm gonna say this is a test. Save as. I need to change this. We're just changing the interface. So what I want to tell you is, you know what? Let's make it more easy. Let's simplify this so it's easier to understand. So I'm just gonna start from scratch. I'm just gonna add two contacts, one and the 10, like this. This is the most simple case scenario. So now I'm gonna add the chemical laboratory, and then I'm gonna add again the button HS4. And I'm gonna just, I don't know, we need something that is linked to it, a motor, which is a pump. I don't know, the one that is linked to this, I think is M4.
You can use a lamp.
Or a lamp, yes. Yes, I'm gonna use a lamp. It's lamp. It's like 1, 2, 3, whatever.
It's the red one, the highest.
Okay, that's the one. And now lamp, we said it was P1, right? Yeah. So I'm gonna save it again. So now, what this text what this checkbox are, with this checkbox you decide which are the variables. Whenever you are in simulation mode, this is how you decide which variables go in this table. If I don't, because sometimes we have like very long sequences, and you don't need everything in there. So now, I'm gonna save it. Even with a simple practice, I didn't add any sensor. It's just one button and one receptor. It was the HSA4, I think it was one.
Yeah, now you see it on the before, in front of you.
Yeah. So for instance, I go see here. If I say I'm gonna open this, then I should see an output in here. Well, I think I didn't. Where is this thing heading? I said. Well, you might need to have the same program. I mean, but yes, I mean definitely he should be able to see it. Now, what I wanted to tell you is, I think I didn't configure it right because I'm not seeing it. Yeah, there's definitely a connection. So why is this thing not? This is a surprise. Yeah, but this is, I know.
Can you also use the hardware button or only the?
I can use the other one. Now I'm gonna do just an. These days we're just changing the interface and I don't see it quite clearly. We need to solve this, but anyways, like the whole idea of this is that you can build your own ladder logic, and that you can connect it in here actually.
Yes.
So we just did it for you in here, but you can do yours as you wish. So this is part of the system we built. But I mean, it's there. If you use it, good. If you don't, well, it's there, so you know it's there, you know. So it's up to you.
This is ready for us. The program.
Well, the program is ready for you.
Okay.
You can build.
And our trainees have to rebuild this.
They could if they wanted to, but I don't think that's the scope. I mean,
okay. No.
Like for instance, in Estonia, they need it. That's a purpose that they need to build it. In here, I understood that it was more about knowing how does it work, touching, going. It's more like a chemical, for the industry, chemical technicians. So I understood that.
But my main question is, when trainees use this class, they have not more options. This is electrotechnic. And our trainees are from chemical side.
No, this is only logic. That's not. So that's not. Was heißt ausdrücklich? Also it's not only electricity.
Yeah.
It's more logic. It's contact plans you can use for building up control systems.
Yeah, this is not the visualization for this. This is only electro.
That's a logical plan behind the function.
Yeah. So since there is no PLC in here, since there is no brain here, we use this as a brain. So this is why we need to go through here. Okay. So this is the controller behind.
Yeah. When I remember we have the visualization in WQ-Digitalisierung. So, und da müssen die ja quasi eine Visualisierung vornehmen, da müssen die ganzen glass bodies and so on, and the direction from right direction or left direction and so on, die Rohre und alles, das müssen die ja auch alles.
Das ist ja nur ein Teil davon. Grundsätzlich sind erstmal die Steuerungstechnik.
Also
die wirfst du mit solchen Sachen oder mit anderen Systemen.
Okay. Ja, wüsstest du jetzt, wie du das den Azubis beibringst, dass sie das nutzen in der Ausbildung?
Naja, es gibt verschiedene Systeme. Du kannst Kontaktpläne nehmen, ja, das ist was hier verwendet wird, und du kannst, when we work with winners, you can use different systems, contact plans like this, or graph set, or what else, logical
Yeah, it's like a sequential programming.
Circuits, and there are different possibilities.
Ja.
And this is one of them.
Kriegen wir das pädagogisch als sinnvoll hin, das irgendwie zu integrieren in die Ausbildung? Oder
Das machen wir ja. Also das, klar, also kann man doch, das ist bloß eine andere Methode dann.
Okay,
also die Steuertechnik machen die sowieso, gerade die Chemikanten.
Ach so, dann machen die das, okay.
Die machen es jetzt mit Winners, und die könnten das aber genauso gut auch mit der.
Okay, and this is only a cloud version, or is this
This is cloud version.
This is a cloud version, okay.
Yeah, so
it is a ready version for.
Yeah, you can use it. I mean, we're gonna release it like next week. Like right now, we're just changing the colors and everything to make it more appealing.
Mm-hmm.
What we did before was just making the program so it works. Now we're working into the static, so it looks good.
Okay.
So this is why there are some models we still haven't put it very very beautiful, but it's gonna be beautiful by the end of the week. So this is the thing. We're planning to launch this as part of our curriculum. In Medusa, what we're doing right now is we are building several experiences.
You have to move this field. Moment. I don't know. No.
Well, doesn't matter.
Was ist mal den blauen an da? Ach nee, das
Nee, das ist
doesn't matter. Just so what we're doing is we're building different environments. So our objective in here is that they begin learning from very simple things. Like the first practice is just you're gonna see just a button and a lamp, and what we're building is that they just learn how to do the logic, so they just click and then you see the lamp just turns on, and something as simple as that, and they will begin learning skills until they actually become proficient. For instance, the one that we're doing for for Estonia, it's a different one. This does not have the capacity to connect to the real world, but it has the same principle. But this is a different machine. So this is a different machine that is called a strapping machine, and we explain it as well, like the other one. No, here in front. So we explain it like the other one, like everything is. We're guiding the student to go from A until Z, so they know exactly what happens with the machine. In here, it has more modules, like for instance, the strapping machine. What is the strapping machine? And then it's like, let's take a look to the machine. If you go back and you see, you're gonna see that it has different sensors. It has different, you'll see animations of how this works, So. And then the objective is that they understand that this is a machine that is meant to strap around packages, pallets, and whatever, so they don't fall down. Okay. So we begin like a rough with animation, so they understand what is it about, and then we actually. Here we have a control panel because they're more focused into what's. This is this is focused for mechatronics. So for instance here. We can open the control panel.
Oh, okay.
And then we'll see, oh yes, this is what I can tell you. So you need to measure here attention of about 24, and you go with the point.
Okay.
And this is how, but everything is guided. The objective is that everything is guided. In here is not really the problem. The problem in Estonia is that the professors that from the school, they are they are about to retire, and they're like 75 or something years old, and they want to keep teaching, but they don't have the time, neither the will to be there all the time in the school. So we are building systems so that they can learn more dynamically the students, and then the professor is still there, so he can actually answer the question, but it's not all time with the students trying to teach everything from A to Z. So for instance, in here, we also say, what is the strapping machine for? We have animations about, so the first part of the strapping machine is the conveyor. So do you see this conveyor belt? Oh, this is the conveyor, and then we make it very, very simple to understand. And we also have this images always accompanying the animations. And for instance, here we have like this arrow in here that makes it very obvious, to understand what is exactly the conveyor. So we explain all the parts of the conveyor, and then we explain how to automate the conveyors. Like first you have to automate the motor, and then you have sensors, and then you have actuators that are going up and down, and then there's like a pneumatic machine. So everything is like well explained, and once you end with the entire operation, then you learn to troubleshoot the system. So we work with a Spanish company who taught us how they manufacture this, and they told us, the most common problems here is that normally the pressure does not go down, because sometimes there's fault in the pressure for the pneumatic system, so it does not go down. And then normally what happens is that there's a clog in the system. These systems are with pressure with oil. And they say sometimes the oil just gets dirty and then just clogs. And then there's any more chance of. So we simulate this in here, and then students, they see, oh, I'm gonna try to find the error, And then they go and measure. Okay, it's not electrical the problem. Oh, I'm gonna go and see here. Oh, this is not anymore. And then until they go around. Oh, the problem was here. So now they understand. And this is like a different. Well, this is more focused for them. And in here, well, what we agreed with Jens was to create this HMI in virtual reality. Human-machine interface. This is mostly what we did for SBG. Now we can always adapt a couple more things, like I told you. We have already developed the multimedia feature, so we can implement it here as well. We have developed some other things we can implement, but if you tell me, I'll say, okay, this we can do it, no problem. If you tell me other idea, I said, oh, maybe this can take longer, but maybe. So right now we're in the good time to keep building. Yeah. So that's something that you actually use. So to us, the objective is that you actually use it.
It looks nice from the others.
Yeah, like this is the original version. Like right now we're making everything more beautiful, but this is functional, so it's good. As long as it works.
Very much work to put all the informations.
Yeah, we're automating. We're automating everything right now, but
now automating 3D twice.
The 3D, the 3D animations,
twice,
yes.
Animation and to connect with the right buttons and so on.
Yes. Yeah. Well, that logic I did it last year, and that was like a puzzle. And then once the puzzle is solved, then it's just connecting things like when you saw the experience in here, like in the case yours, or it could be a strapping machine. So they have different logics. This is a more extensive logic, but the most difficult part was to reach the point where we just have to choose tags and just assign the name, and then everything knows how to connect automatically. So the system knows exactly what to do. So you don't need to think more, you just connect the same names and then it's done. So that was like the most difficult thing, but otherwise, now it's done.
These rungs, are these like steps?
So you can add, this is, well, to us, for instance, in this case, if it's going to be like a 3 rung, well, normally this is the name of this is a rung. So if I have a program with 3, there's no problem because I know what's in there. But for instance, if this one is very extensive, So it's very easy to get lost.
My question is, other ranks where worked, no, not worked, are working after another?
They're in parallel. They're all time. They're working as a real PLC. Like everything is on same time.
Okay.
So if I do a change in here, automatically it does a change. It doesn't have. It's not running in cycles. It's just running in.
I thought there was this were like steps after another. Okay.
Yeah. No. This is all at the same time.
One direction.
Yeah. One direction. So yes, now what we're working on is making it usable for everyone, and for more educational purposes. So right now we're investing a lot of time into making it to share the diagrams. For instance, if I go here, and if I create my diagram, then I just share it with someone else. Like for instance, in here I already have created my diagrams. No, just come back again to the same place. I have my diagram. It's like, oh, I'm gonna share it. Who you want to share it with? With all the teachers, or with a specific group, or with specific students. Maybe you have 3 groups, so you just share it with your group A, and then if you have a group A, then maybe they create their own diagrams, and then it's like, oh, I'm gonna put a note on them, you know. So they share back their diagrams, and you can check in, assign a note, and then just. And the most interesting thing that I haven't updated is not in this version, and this again is mostly related to automation more than the chemical technicians. Is we're doing we have already a program that allows to create automatically the ladder logic with artificial intelligence. So that's the last thing. So we're adding this feature in which you just say, I have these entries and these outputs and inputs. We want to control this process. This is the sensor whatever. I need to have a logic for this, and the artificial intelligence will just drop you the data logic. So we're doing right now a lot of things related to this, but the idea is that people can get trained from A to Z. So again, if you have, I already took notes of what you told me. We're gonna make it happen. Something that.
Yeah, I think when we tested by self and spent more time, then more questions.
Yeah, of course.
We get more questions, and we send it to you.
Yeah, of course.
I think, and now we can einschätzen. We can know which questions we have for students or for us or for the program and so on.
Yeah, exactly. Like if you say, oh, this is better to say it in the slides.
Yeah.
I would just add more slides and then say, we're going to explain this and that.
Well, my question is, are there videos how to use the program? Exist videos or learning videos, or how to use this program? Are there videos, or?
We haven't done any. Right now we wanted to finish we have one, but it was in our last version. Right now, as it is going to become more beautiful, but nothing is going to change place. So now we can actually make a video. Before it didn't make sense because we were just changing this and then put that and then it was changing the way it works. So actually the version that I brought here in December, it doesn't look like the one you have here. Because I was here in December with Jens and he tested it and it was okay, but it has nothing to do with this one, you know.
Okay, I know.
But this is why I come here. I take your ideas and then we just make it simple. The idea is to make it as simple as we can so that actually people use it. So if you have any ideas that could make us improve the program to make it more simple, the better.
I think we have to check what we can do with the program. It is so much for us. As now, it is so much for me.
Yeah.
Yeah.
But what I want to do is
opportunities are big.
Yeah, like we actually did this thinking we can use it in the cell phone.
Okay.
So that people can go on the go. Let me just.
When our trainees use this program, they need their own account, password, and so on?
Yes, we're also thinking on that during this phase where we're developing this sharing things with teachers, students. The best thing, unless you have another idea, the best way we thought it was that you can generate a link which you can maybe forward to your students, and the link will contain your group, and you as a teacher, your group, and it's like invitation links. So you send it, and then they can join your group, and then you'll be able to share whatever you want to this group, as I showed you before.
One moment, please. Coils, are these like flip-flops or something? What's this?
Yeah, this is a reset coil, and these normally come with timers, or this timer retentive timer.
These timers are
in which
yeah.
I need to improve this. So, in order to reset the timer, you need to energize the reset coil.
Mm-hmm. But so, it's not like memory. Okay.
So yeah, like I'm telling you, so we're working right now into mobility, and what we mean mobility is to make it portable, so everyone can have access to it. So this is to us like maybe the most important thing, that everyone can just go and play, even if it's in their cell phone or whatever. Even for the chemical trainees, they can open the chemical station here,
and the trainer can see what the trainees are doing?
That's a good question. Normally, right now it can't. But what would you like to see? I mean, let's imagine. Like you want to see like how they're
the screen. When I am here as a trainer, I will see what the student actually does on his, what he sees on his desktop. It's like a shared desktop.
I see. How many students do you have? I mean, how many students would need this feature at a time? Like maybe 5 at a time or 10 at a time? Or how many?
As much as we have stations.
Yeah. What? How much? 5 stations?
Here are 5. Yes, 5. Yes.
5 stations and 2 students, 2 trainees per station.
Each station can only have one actor.
I think when the trainer see what 5 stations are doing. What? Yeah, it is
not all the time.
Not all the time. Or get information. The station 1 is ready. The station 2 is during the process, and so on. And
it's more in the case if they have a question, so that I can see what they have done.
I understand. Okay, so maybe like the screen sharing, I know it should be possible. I don't know how to do it, but I know it should be possible. But now that you say that if you want to know how far they have gone, what we can do is to set up like, if we say this is extra, for instance, the chemical station, it has like 25 slides. And what we can do is to make like assessments, like you say, imagine like a task list that appears into the user, like you have to do this, and the more you go through a task list, then the more you advance. So I think the teacher should be able to say, I know we can do that. Like we can say, this student has 25%, and he is like in this checking the to-do list. He's in here.
Yeah.
And that's what I think we can do.
Okay.
The screen sharing, I think is possible, but it sounds ambitious to me right now. But maybe it's okay. Possible, It's possible. Yeah.
The checklist is okay. Yeah.
But the checklist with a percentage of advancement, yes, I think we can do it.
Is it automatically that step 1 is check and so on? It's automatically, or has the students are doing? Yeah,
normally it's automatic, but it's upon a change. For instance, in the case of the mechatronics scenario from Estonia, there are some exercises which has a checklist on how to solve a problem. Like for instance, conveyor is not working. Why? Then we have a to-do list. But this is for this specific section, maybe from the 60 slides, this is 1 slide. So it's like, okay, so, but I think we can adapt this idea we already had developed for them.
Yeah.
To make it more like for the entire system, you know, like, oh, we know how much everyone has.
And when a student say, okay, I'm at step 4, and in step 1 is a fail, and she solves the problem and go back, and where
feedback from.
Yeah, it's when checked the first step for the trainer, and say the trainer, okay, student 1 has with station 1 the first step is checked, but the step is not right.
Okay, you mean like an assessment. All right, this is good. So,
or you get feedback directly as a student from the program, and the program says.
Okay, so what I think is, for instance, there are some lessons, for instance, in the chemical station, there are some lessons that.
Ist das nicht notwendig? It's not necessary.
Haben wir noch nie gebraucht.
Well, maybe.
That's not so.
No, it's okay. When he said it's not necessary, then.
But imagine that we want to do maybe like an assessment. Maybe we say, let's gonna ask a quiz about what they learned about the machine. Maybe you can say maybe 5 questions. 5 questions. Say, what is this machine for? What is this pump for? Or what is the sensor for? Like very simple things. And then, or why is this thing? You know, this is the connector.
Yeah.
So then we can say, this person maybe had like 50%, which means that he might need to review lesson 5, 6, and 7, whatever, you know. Like.
Yeah.
At least we will know that they are learning or not. So this is also good for us.
Yeah, I think it's okay. It's good for the students. But that are trainees. They have to look backward and what they learned in your lessons, and then remember, okay, it is right, it's not right. Yeah, was a question.
How much do they spend with these machines normally? Like, half an hour, 20 minutes, 1 hour?
I don't know. Oh God, what has it costed? I think 2,500. I'm not sure.
No.
I know, but the time, like how much do they spend like practicing with the machine?
No, it's different.
For the visualization, 2 days, and for the wie sagt man hier?
There are differences in every course. Sometimes they use it only some days, or sometimes 3 weeks.
Wow.
Für den Regler, was heißt ein Regler?
Das war total. Scheiße, müsste ich eigentlich wissen, mache ich ja. Was wolltest du sagen?
Na, die haben für die Visualisierung 2 Tage, 2, 3 Tage. Und für die Regler, für die Einstellung, wenn die dann quasi die ganzen Zahlen, dann brauchen die locker eine Woche.
Nee, kommt drauf an. Es ist wirklich unterschiedlich. It's different.
Yeah.
1 week or 2 weeks.
We have for this Wahlqualifikation, choosing qualification for the trainees direct during 2 weeks. The duration is 2 weeks for the qualification, and in these weeks are learning about this one or learning about.
We begin with simple steps, learning and/or connections, logical things, memory effects with flip-flops and so on, processes in steps, and they begin with simple things if there's no water, there should be automatically begin the filling process, and after reaching this level, heating process, and so, and after that there will come more complex tasks.
Let me see if I have this chart in my phone. Let me see.
And this needs different times.
I get it.
Wir müssen das ja dann mit den Azubis ausprobieren, Frank. Irgendwie versuchen zu verstehen, wie das alles funktioniert und zusammenhängt und was man als erstes nimmt, was man als erstes macht und warum das mit der virtuellen Brille überhaupt dann notwendig ist, wenn man es dann auch online machen kann. Das ist ja eigentlich nur das Fernlernen, Remote Training with VR.
Yes, I have it in here on my computer. I want to show you something we did actually about this. This is like we did something with a machine for the Mexican Polytechnical Institute, which is like this one, but it's like the big brother. This is mostly the same principle, it's just big. But I'm telling you this. Because I want you to understand, that we can actually go very, very far with the technology right now. And everything requires some internet these days. And hotspot. So it was SBG Dresden. La conexión no es privada, sí, ya sé. Yeah, I did this like maybe 2 years or maybe 3 years ago. But we need to verify set to your account email address.
So, with the Quest 3, we don't need an application. We use browser and go to Medusa.
Yep.
And log in, and then we have it.
Mm-hmm.
Okay. But we need a driver for Medusa, or?
Well, so this is a good thing. In here, yes, you need, if you want to the connectivity, you need the program, but we can send it to you, we just need to install it. What is important to know is that you can also work offline. I mean, you don't need you can only work with the VR simulation mode. If you want, you don't need this. I mean, obviously this is most interesting, but it's not absolutely necessary to be connected to it. But I want to show you. Right now, to us, what we're doing is we're making as much 3D scenarios with different machines and with different also, so that it's more realistic, the learning. So, I mean, in here in SBG it was part of the project, so I'm going to give you access to the Estonian experience as well, so you can use it if you need it. But yeah, the idea is that every day there's more content to use. Now this one. Yeah, just give me a couple of days so that the team can finish with all the aesthetic. But it's done. Like this we're gonna launch a subscription model starting next week.
When you have to do all of them, then we can go to the glass mode and test it. And you can test it from this position, that you have one of this, and you can test it the first button and so on. Okay. It's not so that when you have nothing on this side, that the virtual station works.
So yes, I mean, you have to go through here if you wanted to make it real. But if you don't want to bother into doing any of this, in here in the training environment section, you can say just load digital twin, and you can see the experience. And this is not connected. This is just a this is not connected. I mean, you can try to switch a button, but it's not gonna switch anything because there's nothing connected. But it is. I mean, you can also see the instructions on the videos that we're gonna upload. I'm gonna ask my colleague what he did with the languages, but.
Frank, da müssen wir uns in Zukunft mal damit auseinandersetzen. Okay.
But well, see, that's the thing. I'm waiting for this thing to open to show you. But this project was the first one we connected to the remotely with the VR.
Mm-hmm.
This is actually what Jen saw, and this is what we agreed to replicate with this. Now, the difference of this experience with that one is that this one is an app that is installed into the VR headset. So it's less convenient because you need a headset to see it. But it's convenient in the sense that, well, at least you have it, and then, well, you have it with you. I mean, it's true. Now the problem with the good thing about having it remotely is that every update is automatically, I mean, the system is continuously updating, so you always have the latest version. Mm-hmm. So that's like. Okay. So for instance, this one we did it like 2 years and something ago, and it works very good. They still use it, but it's I mean, now we need to. I mean, if they wanted us to make it like here, they might need to pay. They might need to pay us to make it like remotely so that everyone can have access to it. But good look. So this is mostly the same. This is the same system as the one you have in here, just more. This is for another school. So it has also 2 tanks. There's a recirculation. There are bulbs. There's a heater down here, and it's the same. It's almost the same. The same training system is just bigger, you know. But this also works connected remotely. Mm-hmm. So this is.
Mm-hmm. Nice.
Yeah.
And you build it?
In the 3D model, yeah.
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 Fine.
So this is an old version. I mean, this for instance, it works in Unity because you can install the app and Unity, and the VR headset has the processor. The challenge in here is that normally the VR headset assigns only a part of the processor to the browser. So you have to make it really lightweight so it works fine. Otherwise, it just lag and then. So this is the challenge with the browser. I mean, you have to make it extremely light so it works. Or even the cell phone or mobile phone. But and this we didn't care about the pixels or the number of how heavy it is, because it was only headset and camera. So this was another challenge, but it's fun. I mean, right now we're trying to make them to update the system to the new one, but it's a school, so it always depends on public funds, and then we'll see maybe next year.
We would see.
Yeah, I mean, the problem about Mexico is that it's all about politics. When there's elections, they always invest in technology so that, oh look, the school was this big while I was there, and then there's always investing money. So, but right now it's not elections, but next year there will be. So I know that next year they'll invest in these sort of things. So this is the way. I mean, everywhere works differently. In Estonia, I like it because it's very flat. There's no hierarchy. Like it's very reduced. So. I was quickly talking with the principal of the school, and then one more, and then one more. So it was more easy to just go on and get more projects. So each country has its advantages and disadvantages. But you just need to know when.
More country and andere Länder, andere Sitten, sagen wir.
Ah, sí.
Andere Länder, other country and.
Other people is different also, yes. So we need to adapt. This is why we work in different countries, because there's always a good time to invest in every country. So sometimes it's not very good in here, but it's better in there, and sometimes it's not good in here. And sometimes when nothing happens, then the European Union gives us funds, like for instance in this case, which was good, because we began working for this project during the pandemic. So
yeah.
No, I will play a bit later, 2022. It was like economy was low, so it was good to have funds for this.
Okay.
So anyways, just let me know if you need something else. Like I'm gonna give you access. I'm gonna need your emails. You'll send me your emails, so I'll just send you like I'll create access for you, so that you can test it. You can give me. More ideas,
feedback at the next Teams meeting.
Yeah,
I think we can discuss this.
Yes, or if you haven't before, then just send me like some ideas, and then we can get working on that. The first part.
Yes,
is recording right now?
Only the part to start Aurora. Is Aurora including the driver software or?
So we installed it in here. But yes, I mean you let me know whenever you have like the computers on, and I will send you the installation program. And the only requirement about this is that you need to send us how's it called? You need to send us a key, and we send you back a key, and then it's activated.
Okay.
Nimmst du auch?
Noch nie. Can I close Aurora?
Yes, of course.
Oh.
So I'm just gonna close Aurora. We have to open it. We have to go through main, recent projects, open the most recent project, and then just go runtime and go runtime. Now, if the LED in here is not green, it's good. You need to shut it down and shut it on again and turn it on.